Welcome back, folks. So in this video, we're going to do a modeling problem using now quadratic functions. Again, we've seen modeling problems or word problems before with linear functions, and now we're just doing the same thing. It's just the situation finds a quadratic function to be more appropriate. Okay, so in this scenario, we have Phoebe here who is flying to Mars in her spaceship, as you do, and suddenly she just changes her mind, so she decides to throw it in reverse and then leave. So you could think of it as if you're playing Mario Kart, where you're driving, and then if you hold down B long enough, you will brake and slow down until you stop, and then eventually you're gonna throw it into reverse. That's what Phoebe's doing, or what she's trying to do. Hopefully she doesn't crash. Right? So I've drawn a little picture here. So retro rockets are just rockets that push from the front, so they push you backwards. Here's my picture of that scenario. Okay, now we're going to label our variables here instead of x and y, t and d, where d is our distance from Mars, or Phoebe's distance from Mars, right here. And then also the t, our time, or our independent variable, that's going to start when she fires her retro rockets, because if she's just going forward, then the path that she takes is going to be different from when she fired her retro rockets. So the equation that we're going to make here in part A is only relevant for the times in which she's using her reverse rockets. Okay, so part A here is create the equation. It doesn't say that. I forgot to write that. But here's what we know. We know that when t equals 1, 2, and 3 minutes, her distance from Mars, she is still getting closer at 425, 356, and 293. So let's just remember, we're going to use our standard form equation here because it's not obvious that any of these points is the vertex. In fact, they probably aren't the vertex. So remember, y equals ax squared plus bx plus c, or for us in this case, it's going to be d is equal to at squared plus bt, plus c. Okay, so let's create the points that we know and therefore the equations that we can start with for our system here. So I know at t equals 1, our distance is 425. Our second point is at 2, 356. And our third point is, let's make this a little bit cleaner, 3, 293. Okay. Again, all I'm doing now is I'm gonna plug these points in as for t and d, and we'll have 3 equations with just 3 unknowns, a, b, and c. So I'm just going to do that real quick and I'll get back to you. Alrighty, so here are my equations after I plug them in, and I've also cleaned them up a little bit. So instead of saying like a times 2 squared in number 2, it's just 4a. Okay, so I have that. So let's actually solve this system again with elimination here. Alrighty, so again, because all the coefficients for c are just 1, they're all just plus c plus c plus c, makes it really easy to eliminate them. So I'm just going to take equation numbers 1 and 2 here, and I'll subtract them. Again, I'm doing equation 1 minus equation 2. There's no reason you couldn't do equation 2 minus equation 1. It's totally fine. So if I do that, I should end up with, let's see, 69 equals a minus 4a should be negative 3a. b minus 2b would be minus b. And then c minus c will just be 0. Okay, and that's going to be equation number 4, so let's number that. When I look at equations 2 and 3, I'll do again equation 2 minus equation 3. The reason I'm doing these, by the way, is just because it's easy for me to do the top one minus the bottom one. Just easier on my brain. So let's see, 356 minus 293 should be 63, I believe, equals negative 5a minus b once again. Really nice here, because now we have equation 4 and equation 5, and I don't have to do any multiplication to readjust any of the equations here, so I can just subtract them now. Again, note here, I'm subtracting the equations because I have negative b and negative b, so they're the same sign. If you, in one of them, ended up with negative b and positive b, then you would want to add the equations. Or conversely, you could multiply them by -1 and then subtract. But either way, just make sure that when you, however you combine them, whether it's adding or subtracting, you're eliminating something, because that's the whole point of this process. Get rid of the variables one at a time until you end up with just one that you know. Okay, so 69 minus 63, and I'm going to write this resulting equation over here. That'll be 6 is equal to negative 3a minus 5a, so that'll be plus 5a. Sorry, minus negative 5a. So that should be 2a right there. Leaving us with a is equal to 3. Great. We're a third of the way there. Actually, probably more than a third, because we've done all the hard work at this point, because now we just need to substitute a back in. So I'm going to substitute a into equation number 4 here. If you want, you could substitute it into number 5 as well. Nothing wrong with that. That'll leave you with 69 equals negative 3 times 3 minus b. I'm going to kind of shortcut the algebra here a little bit, but you should end up with b is equal to negative 78 here. Last part here, take a and b and throw them into one of the original 3 equations to get c. And we'll do equation number 1, because again, there's no coefficients here, so it just makes the plugging in easier. 425 is equal to 3 minus 78 plus c. That'll leave you with c is equal to, oops, sorry about that. That should leave you with c is equal to 500 here. Alrighty. If I combine these 3 variables or parameters and throw them into our equation representing Phoebe's distance in relation to her time since firing her retro rockets should be 3t squared minus 78t plus 500. If you hear a beeping sound or a whining sound, I'm not sure what that is. I apologize. And that should be our equation here. This one video is already a little bit long, so I'm going to cut it here. In the next video, we'll be able to handle the rest of these questions, talking about Phoebe's journey. Alrighty? See you in the next video.